Good morning, and you're very welcome to today's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from today. Good morning, Cathal. You're very welcome, and good to see you again. And we'll be introducing our speaker now in a moment. But just before we do that, we want to just to remind everybody that Ireland is intensifying its efforts to meet climate targets and transition to low emissions agricultural sector. Understanding how carbon is stored and measured on farms has never been more critical. And in response, researchers, policymakers, and farmers are increasingly turning their attention to the potential of soils, hedgerows, and farmed landscapes to act as carbon sinks. And today we'll be discussing the monitoring, reporting, and verification of farm carbon stocks. And we're delighted to be joined by Dr. Stuart Greene, who is a research officer in Teagasc. Stuart, good morning to you, and you're very welcome to the webinar.
Thanks, Mark. Hi, Cathal.
Morning, Stuart.
So, Stuart, you're working in this area for some time now. Maybe could you give us a little bit of background to the work that you're doing in this area? And I know you come at this from a spatial perspective as well.
Yeah, then my work has always been about what's called Earth observation. It's using satellites and drones and aircraft to look at the agri-environment and sort of record what's going on and give information to policymakers and farmers about changes and improvements and disimprovements and so on. And as you can see, we've been looking at hedgerows for quite a while now, so we've got a good handle on them, which we'll talk about.
Great. And I know your presentation, you've got some nice graphics and imagery for us to look at. So looking forward to that. Cathal, you're going to be managing questions this morning.
Yep, we have a Q&A tab there, Mark. So just to remind everybody to get your questions in the whole way through, and we have Stuart with a very interesting presentation coming up. So we'll chat at the end.
Great. Thanks, Cathal. So, Stuart, when you're ready, you can share your screen with us. And while you're doing that, just to remind everyone that today's session is being recorded and will be available on the Teagasc website and the YouTube channel. And you can also get a podcast version of the webinar as well if you want to catch it on the move. So, Stuart, we'll look forward to chatting to you afterwards, and do send us your questions using the Q&A tab there, as Cathal said. Okay, thanks, Stuart.
Okay, thanks, Mark. Morning, everyone. As I said to Mark there, that I'm in the spatial analysis part of Teagasc in Red P, and all my work is involved sort of observing the agri-environment and the farm landscape, often from space using satellites. But most of the stuff I'll talk to today is using drones and other aircraft to see really close up what's going on. I'm talking about above ground carbon stocks, how we look at them, how we measure them, and how we verify they're still there over time. I want to acknowledge early on that I'm drawing on work of colleagues Lillian O'Sullivan and Tom Dwyer in the Signpost program, and some of the work one of my WASH scholars is currently underway, Owen O'Reilly, looking at new ways of doing some of the things we'll be talking about. So principally, we're talking about above ground biomass and how it stores carbon. And very simply, I'm sure everyone on the audience knows, but as plants grow, they use through photosynthesis, they absorb carbon dioxide. And this essentially is what forms the biomass, the plant. So that within the living tissue of the plant, the wood, the leaves, and so on, is carbon. And on farms, the main long-term stores of carbon in biomass are the hedgerows, the trees, the scrub, the woodland, and the forestry. I'm not really going to talk much about sort of forestry and woodland today. There's been other talks on those, and the methods for measuring and estimating carbon are very well developed in forestry. The hedgerow work here is newer and of more interest because of that novelty. And there are tools on the Teagasc website where people can go in and get good estimates of the carbon store and the long-term sequestration of woodland on their lands. So we're really going to be talking about hedgerows. And just to sort of set the scene. A hedgerow is a line of shrubs or trees maintained to form a boundary for property. And this is any form of hedgerow. So even a gappy hedge where there's at least, say, 20% of the boundary is a hedgerow species, that is considered a hedgerow now. And in this work, we probably do include tree lines. This is hedgerows, sometimes with trees growing in them, or sometimes think of an avenue of trees as a sort of ornamental feature. These are included as well. And these are landscape features. And under the regulations, removal of landscape features is not permitted if you're getting payments, except in very exceptional circumstances under the Agricultural Economic Conditions rules. The exceptions are on the Teagasc website and in other sources, but generally you can only remove in the case of safety or access for building. One of the reasons why carbon in hedgerows has become a hot topic is the idea of carbon farming. This idea that you can farm in a way that increases carbon, and farmers would hope to get paid for doing that, whether that's through just doing the activity or by measuring the amount of carbon stored or increase stored and getting paid for that amount of carbon. And within this whole environment of farm carbon, we have this principle of MRV, which is measurement, reporting, and verification. So measurement is the size of the impact. So how many more hedgerows have you planted? Reporting is identifying the source of the impact. So these are where the hedgerows are on this farm, in this part of the farm. And verification is independent evidence that hedgerows say have been planted or allowed to grow. And this is really very important because unless carbon markets have reliable evidence, the level of payment is much lower. Really, the more evidence you have, the higher the value of the carbon you're claiming. And within that sort of whole environment, for the last sort of 15 years in Teagasc, we've been trying to answer a number of questions. Sort of, where are the hedgerows? They're on the farm, but we need to know exactly where they are across for the whole country. What are the dimensions of those hedgerows? And then, how does the size of the hedgerow relate to the biomass? So hedgerows are unusual sort of features in the sense that they contain a lot of biomass for their size because they're very old, they're very dense, they've been managed in such a way to increase the biomass. So if you're trying to make a stock-proof hedge, one of the ways you do that is by increasing the amount of material, and that stops the animals getting through. And then in the last few years, there's been more concern about how is it managed. So as we'll see, a very tightly managed hedgerow that's cut every year, very neatly, that has less value for carbon than a more irregularly managed hedgerow. So we need to be able to detect how hedgerows are managed. And then how is it changing over time? Is the hedgerow getting bigger? Is it being cut down? Is it being removed? And Teagasc has been, as I said, researching hedgerows for a good while, 15 years. We've had Teagasc funded projects, we've had EPA funded projects, DAFN funded projects, all trying to answer all these different questions, and all the reports and analysis on the Teagasc websites. The first try was a hedgerow map from 2005. Now, this was based with an image analysis of hedgerows on aerial photography from the Ordnance Survey. And it took about 2 years to do. The amazing thing is that the technology has changed so much with new analytical techniques, new computer processing power, and advances in machine learning and AI. I suspect we could do the same thing in about 2 months now compared to 2 years. And those results were provisional, but have turned out over the years to be actually very accurate. And they estimated that approximately 6% of the country was covered by hedgerows, scrubs, tree lines, etc. In 2005. And if you think that in 2005, maybe 11% of the country was under forestry, you can see already the relative value of all this, what we called boundary biomass, the hedgerows, compared to the forest stock. There are other sources of information from Europe, principally. One that I've not put a slide on because it's only just been released is from Copernicus. It's called the High Resolution Woody Features Layer, and this really quite accurately now independently maps anything above 10 meters wide, 10 meters in size that's woody. So this is the bigger hedgerows, bits of scrub, woodland, and so on. So this is an independent source of remotely sensed mapping of hedgerows and woody features. However, Lucas survey is underused in Ireland, I think, and this is a physical survey. So every 3 years, contractors are sent out to 4,000 and more points across Ireland to make observation of the land use and the land cover. And one of the observations they make is the occurrence of hedgerows. And not only do they record whether hedgerows exist, but they make some observations on drainage, ditches, but also whether the hedgerow, as they call it, is managed or unmanaged. Now, we probably wouldn't use that phrase anymore. We'd probably talk about regularly managed and irregularly managed. But you can see there the sort of geographic distribution. So the managed hedgerows are all, on the east coast. And in the middle there, the unmanaged hedgerows in the sort of south and the west. And there on the right, we can see where the stone walls occur, up in the northwest, principally. And that's quite useful because stone walls are quite difficult to map from any of our sources. So we don't really have a good map of those. So this helps us distinguish between hedgerows, stone walls, and another source of confusion in the work we talk about is vegetative banks, but we'll talk about that in more detail in a few slides. For a long time, the only estimate of hedgerows was the original Teagasc hedgerow map from 2005. But in 2022, we had published the first national land cover map. We were heavily involved in the development of this. It took 10 years, in fact, to develop fully the system that would produce it. And we helped evaluate the National Land Cover Map. It was driven by ourselves, the EPA, National Parks and Wildlife Service. It was derived by the Ordnance Survey, or Tulcha Éireann, as they are now. And it's a very, very high quality map. It shows a great deal of detail down to 0.1 of a hectare. It essentially maps every hedgerow as well as every other land cover in the country to great detail. And the first iteration, published in 22, was baseline for 2018. There is a commitment to produce a 6-yearly cycle, so the next one will be based on 2024, and we'll be able to see nationally the difference in this case, hedgerow stocks between 2018 and 2024. If you look at the statistics they produce, they claim that hedgerows are only 3.18% of the country, which is a lot less than the 6% I mentioned earlier. But this is because they have a very tight definition of hedgerow in terms of height and width and so on. If you were to include, as we did in our original map, scrub here at 1.84 and tree lines at 1.04, you're actually up at 6%. So our original estimate was very similar to the estimate here in the National Land Cover Map. As we'll see in the next few slides, it's important that we think about hedgerows in terms of area. That's what is important for biomass and for carbon stored in the biomass. But I know traditionally people have talked about a length of hedgerow, and certainly the regulations in the EIAs on, digging up a hedgerow talks about replacing it with twice the length. So here are the statistics from a project we had called Briar, which I'll talk about in a bit more detail later, that breaks down the length of hedgerows in per county and for the country. So we've got roughly 700,000 kilometers of hedgerow in the country, which is an awful lot. But what we did here, we broke them down between unshared boundaries. So this is where, the hedgerow is bounding a farm, but it's maybe the other side is a road or a stream or a commonage or some non-farm property. Shared boundaries, these are hedgerows between farmers. And these generally are, if you were to look at the landscape, you can see that shared boundaries are generally the bigger hedgerows than the other two. Good fences make good neighbors. And then lastly, around about a third of the hedgerows are internal farm boundary hedgerows, marking off fields within the farm. And if you think about it, between, say, a shared boundary and, say, road hedgerows, the farmer only has complete control of about half of the hedgerows on their property. So this does make it difficult sort of tracking changes and the causes of change, because you might get a letter from the council saying you have to trim your roadside hedges. You can't really manage half a hedgerow if your neighbour isn't interested in managing in a certain way. So really, it's about half the hedgerows on the farm are in the farmer's control. So we have a pretty good idea now of where all the hedgerows in the country are. And what we need to do now is think about, well, how big are they? How much biomass do they contain? And because the more biomass means the more carbon, how much carbon do they contain? And there are two approaches we can take. We can use a 2D approach, looking at imagery. This could be satellite imagery or aircraft imagery as the previous example, or drone imagery. Or we can do a 3D approach. And there are two approaches to this, one called photogrammetry and the other called LiDAR. And I'm going to talk about LiDAR today. And this gives us a three-dimensional model of every element of the farm. So it has lots more applications beyond just measuring the size and shape of hedgerows and trees. It can be used a lot for farm planning, for putting new roads in. It's significantly useful for looking at overland flow and water quality issues. But we're going to talk about using it to look at hedgerows. So a LiDAR is a laser scanner. What it does is it sends out from a device in our case, it was a drone. It sends out millions of laser pulses a second, scans across the flight path of the drone. Now, this laser is exactly the same strength as a laser pointer, so you can't see it. It can't do any damage. It's not dangerous in any way, but it does scan extraordinarily quickly with millions of dots of laser pulses. And what happens is the laser pulse is coded. So when it reflects off something off the ground, it could be a leaf, a branch, the ground itself, a building, and comes back to the sensor is able to calculate how long it took to go from the sensor to the object and back, and therefore can calculate the exact position of the object it bounced off. And here you can see the sort of blue and black image at the top. This is a laser scan taken by drone for a hedgerow. And each of those tiny little black dots, that's a laser pulse bouncing off a branch, a twig, a leaf. And because there are so many dots, and because sometimes a pulse of laser light is only half intercepted by a leaf and the rest of it carries on towards the ground, we can actually see inside the structure of the hedgerow. We can see the ground, we can see the basal area of the hedgerow in many cases. Sometimes we can see the ditch, sometimes we can see the bank, or maybe a relic stone wall that's been covered by a hedgerow. And so it gives us extraordinary amount of detail of the structure and the volume of the hedge. And I'll just give you a little video here of what this looks like. So this is not a real video. It's a computer generated video from one of our laser scans that shows the quality of the data. So We zoom in. Each of those little blobs is a laser pulse coming back, and the laser pulse is coded with the color of the object it struck. So we can see there that hedgerow has got sort of gorse on one side. It's got a number of trees popping up out of the hedgerow. And as we zoom in, we can see that really get detail of the structure of the canopy of the hedgerow. And you can see underneath, you can see the sort of black, what's known as a void. These are occasions where the hedgerow is so dense that the laser can't penetrate through the canopy. But we can still use it to give us the information we need on the volume and the structure of the hedgerow. And it allows us to create for the farmer 3D models, and it helps us in producing the habitat maps. So most of this work was done under the Signpost program. We flew, I think, 92 farms with this technology. And as well as doing the carbon assessments and the 3D modeling that we'll talk about, we did also produce habitat maps for each farm. And the laser survey really helps improve the accuracy. So typically you might get, say, 85% accuracy using conventional imagery for these habitat maps. But with the LiDAR, we can get towards 95%. So they are very, very accurate. But I'm not going to talk about biodiversity mapping. I think Kean White next week from Trinity will be talking about a project they're doing using the same technologies. So I won't steal that thunder. Instead, we'll talk about how we convert the laser scan into an estimate of carbon. Now, the first project we did was called the Hedgerow Carbon Project in 2011, funded by the EPA. Myself and Kevin Black did this work where we scanned a number of hedgerows with a LiDAR system. We can see there at the bottom left, this is a sort of transect. So if you cut across what's known as the point cloud of the LiDAR, all these little responses, you can see there, you can see the ground, you can see the ditch, the bank, and then the scatter of points above, which is the leaves on the hedgerow. Now, at the time, we didn't have what's known as an allometric model. We didn't have a way of relating hedgerows volume to carbon based on real data. So what we did was we treated the hedgerows as little trees. And there's lots more information on tree carbon storage and how you calculate biomass from the height and the canopy size of the tree. So we treated them as little trees, and we got some good estimates. We found that in this study that we found that hedgerows sequestered about 1.5 tons of CO2 per hectare per year. So at this point, I just want to say that sequestration is how much a plant increases its carbon store over time. This only happens really if you allow a tree or a plant to get bigger. Once you're managing it and keeping it a fixed size, the amount of sequestration really drops very, very low. And for a mature hedgerow that might be 100, 150 years old, if you're tightly managing it, you're really not adding much carbon because it's only as the hedgerow gets bigger does the carbon get stored. So what we've been talking about in Signpost, and we'll be talking about for the rest of this project, is measuring how much carbon is stored in the hedgerows on your farm, not how much is being added if you allow them to grow. But our estimates were roughly 1.5 tons of CO2 per hectare per year. And again, when I'm talking about a hectare of hedgerow, I'm not talking about a hectare of land surrounded by hedgerow. I'm talking about a hectare of hedgerow. So if you take an average sort of Irish dairy farm, 80 hectares in size, it's probably got about if you pushed every hedgerow on that farm together, it would cover about 2 hectares. And so that's what we mean by per hectare for a hedgerow. But it was successful. We did get some estimates of storage, and we've used it. We used the methods on other sites since then. But really what we needed was some real data on how much carbon is actually in real Irish hedgerows and link that to the dimension of the hedgerow, which means that in the future, if you measure the dimensions of the hedgerow, you can then estimate the carbon in it. So this was Lillian O'Sullivan's project, Farm Carbon, in Johnstown Castle. It was a very big project. Took a lot of work, hard work, and very detailed. So not only were they looking at the above ground biomass in hedgerows, but they were looking at how much biomass is underneath the hedgerow in the soil, how much biomass is captured in the dead wood and the litter that surrounds the hedgerow, how much is in the soil, not just the roots. We're just going to be exploiting the above ground carbon in this talk. And you can see it's a big, dirty job. If you want to know how much carbon is in a natural hedgerow, you have to dig it up and go off and measure that carbon. So it's quite destructive. So it's not something we'll be doing very often. But they did, I think, about 25 hedgerow samples across the southeast. And so it gives us a very good estimate of what's going on in Irish hedgerows. So they found that on average, Irish hedgerows had about 58 tons of carbon per hectare stored. Okay, so this isn't sequestration. This is, if you dig up a hectare of hedgerow, you will get 58 tons of carbon. They found that the below ground biomass was about 10 tons of carbon. Okay, so less important than the above ground. They also, again, found that irregular, less intensively managed hedgerows have more above ground biomass than very intensely managed hedgerows. So if you give the hedgerow a short back and sides, it has less carbon than sort of shaggy looking, irregularly managed hedgerow. And that management regime does have a very strong effect on carbon stock changes. And in fact, they found that for the period they were looking at, I think 2018, 2023, that in the two counties they were looking at, Waterford and Wexford, that in fact hedgerows were a source of emissions because the hedgerows had been managed and some had been removed. They show that international studies show that if you do allow hedgerows to grow, you get approximately 1 ton of carbon per hectare per year, but only if it's allowed to grow. So what we do for the signpost farms is we use the LiDAR to give us a really good model of the shape, the height, the volume of the hedgerow. We take the data from Farm Carbon that showed us how much carbon for a typical hedgerow is there. So they measure the dimensions of the hedgerow before they cut them down to measure it. So we know we've got an equation that relates volume. And then we survey every hedgerow using the LiDAR on the drone. So we can give a carbon estimate for every single tree, hedgerow and bit of scrub on the farm. So this is what we do, talk us through. This is a LiDAR scan of one parcel of a signpost farm. Every single dot there is a laser return. It's color coded so that blue is low, red is high. So you can see there's some very high hedgerows there and tree lines, and that the farm generally is sort of draining down towards the northwest. That's what it looks like in the 3D model. So what we can do is we have mathematical techniques that turn all those little red blobs, which are actually the hedgerows, into a volume model. And we can then, what's called a canopy height model, and we can then calculate how much in terms of meter cubed of material is in those hedgerows. And then we can use the allometric models. Once we've mapped the base of the hedgerow, we extract the canopy height model that gives us the volume of the hedgerow, and we convert the volume into heights and carbon estimates within each hedgerow. And then the farmer gets a report, looks something like this. It's a habitat map showing where all the habitats are, and we classify hedgerows and tree lines as habitats. And then it tells the farmer how many tons of carbon are on the farm. And again, this is what's on that farm now. It's not what's being added to. It's not sequestering, it's the storage. And this, in this case, 270 tons, this is carbon that's been stored literally over generations. Okay, some of these hedgerows are 100 years old, so it's it's a legacy issue you've got there. Another example is a much bigger farm. This we found there was 390 tons of carbon in those hedgerows on that farm. Tree lines had a much smaller amount. The height of the hedgerows was only 2.3 meters on average. So these aren't huge objects, but because there's a lot of them and they cover a lot of area, they add up to give a lot of carbon storage. And on this farm, if we gave a very generous estimate of 2 tons of carbon per hectare each year in sequestration, if the farmer didn't cut them this year and let them grow on for a year, they would add another approximately 11 tons of carbon onto the farm. So we can map the hedgerows, we can measure the volume of the hedgerow and use the equations from Lillian's project to give us an estimate of carbon in terms of tons of carbon in every single hedgerow, a particular hedgerow, not just an average value. So therefore, we can now use those equations to map nationally the status of hedgerows. So in the original land cover map that we saw a few slides ago, it just said hedgerow. So we invented a GIS method to separate those hedgerows based on their shape between irregular and irregular managed. And then we can apply the different equations on average to those so we can get a total carbon stock for hedgerows for every county. And then when the next iteration of the land cover map comes, we'll be able to see, okay, well, this is the increase or decrease in regular or irregular hedgerows, and this is the increase or decrease in carbon. So we've now got really good tools to see what's going to happen and actually give proper figures for the change in carbon stock on Irish hedgerows. But as we'll see, unfortunately, our studies and other studies are still showing that really we have net removal of hedgerows, even with the rules in place about replacing them with twice the length before they're cut down. In practice, that doesn't seem to be happening, or it's not at least showing up on our records. And again, the farm carbon study showed that there was a net emission in Waterford and Wexford from hedgerows of about 0.3 of a tonne per hectare per year. Now that's important. So if farmers are thinking, well, we need to get credit for what's going on our hedgerows, at the moment, the farmers in Waterford, Wexford would probably, be owing money rather than receiving money, because they've been. I think the analysis showed there was quite tightly managed. And in our Briar project, we estimated that between 95 and 2015, there was approximately 3% of the hedgerows disappeared. Now, it's not all by any means, certainly in that period, wasn't due to farmers. So the top pair of images show sort of classic farm restructuring. Internal farm hedgerow boundaries are removed to make one big field that's easier to manage. But in that period, of course, it's the Celtic Tiger period, lots of road building, house building. So a lot of the hedgerow removal was down to other activities beyond the farmers. But since 2015, a lot more of the removal has been more and more, the percentage of it down to farmers has increased. So I think within the Department of Agriculture, obviously, because hedgerows are landscape features and they're protected under the payment schemes, they're looking at new ways of looking at hedgerows and seeing, especially if they've been removed. And I think it's been brought in as part of the AMS. Now, one of the techniques they use is one we helped develop is using a satellite technique. So most of the time, as you can see here, the country is cloudy, not very good for looking at hedgerows. But these microwave satellites that we now use, called the Sentinel satellites, that's the same day, but taken with a microwave satellite, a radar satellite, so we can see through clouds. And we showed in the Briar project, it's very, very good at spotting change, and it's very, very good to spot if hedgerows have been removed. So that's one of the things that's being developed in order to monitor the hedgerow stock within the context of farm payments. There is another threat to hedgerows that's increasing, and this is wildfires. Hitherto, we only got reports on whether a wildfire occurred. Now we're able, through the Copernicus service from the European Space Agency, to accurately map where they're occurring. So again, as wildfires occur in forestry and in upland areas, as they get towards the enclosed areas, they can damage and destroy hedgerows and other forms of farm biomass. So we can map very accurately where they are and record. And this is the sort of thing that's important if you're thinking of hedgerows as being part of a carbon farming process, is that you need to show, you need to verify and provide evidence that they are intact for each year of the payments. So lastly, we have a lot of this great technology that we can use and observe and model and understand the hedgerow. But I think the one take-home message for anyone with hedgerows on their property, there's lots of rules. They are protected, and we understand their value in terms of habitats and biomass. We know that we can't cut during the nesting period, that they're valuable sources of protection for livestock. But in terms of carbon, so this is just a random hedge I picked. Okay, so I don't know if this hedge wasn't removed or anything. It's just a random hedge. It's 180 meters long. What I call a bog standard hedge. Its average height is only 1.7 meters. The area it covers is approximately 500 square meters, but that has nearly that has 2 tons of carbon in it. Okay, so let's say the farmer followed the rules and wanted to remove it for, say, there was a steep slope there, and so for farm safety reasons, for access for machinery, they went through the process to have it removed and planted twice the length as the rules stipulate on the EIA rules. But even if you did that, if we know that it takes we know the sequestration rate for new hedgerows and growing hedgerows. So even if you replaced it with twice the length, it'll be 12 years at least before you get back in your new 2 hedgerows what was lost in the original hedgerow. And if you think about the really big wide hedgerow on the right there, if you were to take out a section of that, your farm will probably be in carbon deficit for a generation, unless you do something significant, for instance, planting a large area of woodland or forestry. So, don't think of the length. You're not replacing like for like. Okay, the carbon loss will be lost for a very long time when you remove a hedgerow. That's a slide we've been pushing around at various events. It shows us the difference. Again, these are real measurements. They're not theoretical or anything. This is one of the Signpost farms, and we can see that this low-cropped hedgerow in the front contains only a quarter of the carbon that the more irregularly managed hedgerow with trees in the background contains. Okay, thanks for your attention, everyone.
Thank you, Stuart. Really enjoyed your presentation. Those graphics and the technology is really extraordinary now, how it has come on in the last 10 years, the LiDAR, and there must be huge computing power required
Yes.
to process all of that data. You've probably posed a few questions there, just I suppose from a hedgerow management point of view. I'm sure we've lots of people here joining us today who are working with farmers on a daily basis and interested to know what is the best way to manage hedgerows. And I know Catherine Keena has and Teagasc has advice around that. But what obviously retention is number one. That you make that point really very, very clearly there, that it's not a like for like just replacing a hedgerow. But in terms of that tightly managed hedge versus a more maybe slightly wilder hedge, it seems from a carbon point of view and probably also from a biodiversity point of view that it's more of a positive thing to do is to maybe not be so what's manicured with
Yes.
our approaches.
Yeah, I mean, I know farmers have lots of reasons for managing hedges in certain ways. And you certainly, you can't let a hedgerow grow on forever, because eventually it turns into a forest, and you don't want that.
Mm,
Um, but you have to strike a balance. So if you have got tightly managed hedgerows that are under your control, you give yourself a break. Just cut them every 2 years rather than every year or every 3 years, and let them get a bit bigger. Catherine encourages the idea of letting one or two of the plants every, say, 50 meters grow up to be a tree within a hedgerow. That doesn't have an awful lot of impact at all on, say, the agronomic performance of the field that the hedgerow is surrounding. So I think, you're not a bad farmer if your hedgerows are a bit shaggy looking, I think is the
mm,
message. We
yeah.
need to get away from this sort of neat and tidy idea, and sort of allow the hedgerows to grow out a little bit.
Yeah, no, it's a really good point. The you made a distinction there between carbon measuring the stock versus the additive effect of hedgerows, which is probably smaller or negligible based on what you were saying there. Why is that important? Why is it important that we are measuring the stocks and just linking it to that bigger picture in terms of inventories and all of these complicated equations that are done to look at what the net emissions are from the sector.
Yeah, I think people sometimes get confused with the difference of the two. So if we measure the stock because we have to have what we
Mm.
hold what we have. In terms of, say, payments that sometimes are talked about, or farm carbon and farming for carbon, and the inventory, that's all about change. So that's you'd only get paid for an increase in the carbon stored on the farm, not for what's already there. And in terms of the inventory, if, say, for instance, in the National Land Cover map, we see that there's a 1% reduction between 2018 and 2024 in hedgerow, because we know what the stock was, we can actually then put a figure on that change, whether it's negative or positive, on the inventory accounts. So that's the difference. The stock tells you what you have. The sequestration tells you how much you're adding to what you have.
Yeah. No, that makes sense, and I think it's important to make that point. Cathal, some really good questions coming through there.
Yeah, just to start off, Stuart, a lot of compliments coming in. People are really enjoying this one. But just as a follow-up to the stock question there, have you any comments maybe on how we could assess past management versus today?
It would be it's tricky in terms of getting information. We did do a little bit of this on the Briar project, where we looked back at the only source of information really we have is the 1995 aerial survey of the country, and that does tell us the status of the hedgerows in the past. And obviously, we know there's been a net reduction. And if you look at that imagery, you can see in 1995, the hedgerows were probably managed more in the way that we'd want them to be managed now than, maybe 10 years ago. I will say, in terms of looking at the change in the stock and change in the amount of hedgerows, very, very, very young hedgerows, a freshly planted hedgerow is really not going to show up in our systems for a year or two. So there's always going to be a little bit of a lag between, planting a new hedgerow and it showing up, just because it's so small as an object. It might just look like a fence to us. So there's a little bit of ambiguity, but it is clear from everyone's studies that we have fewer hedgerows now than we did in 1995.
And on that, I suppose there's a kind of question here around, like, does a hedgerow reach a point where it's maturity and it can no longer take up carbon, it's almost saturated, or is that very open? Maybe that there's different types of hedges.
Yes, there is different types of hedgerows. There are different things, but there is, it's like it's the same with the forest. At a certain point, it's like most middle-aged things. It just sort of starts ticking over and stops adding much to what it's doing. So hedgerows can reach a point where they're saturated if you keep them in the shape and size they are. And even the soil underneath the hedgerow, eventually, it just soaks up all the carbon it can do. So you don't even get increases in soil carbon. But even that very mature hedgerow, that maybe 150 years old, if you stop managing it and maybe let it get wider or taller or the odd tree come out, that then will start really increasing the stock of carbon in that hedge.
And kind of a technical one here, but is the area of hedge additional to the forest stock or a subset?
In the inventory, it's different. Yeah, it's not considered. And in fact, I don't think up until very recently it wasn't calculated fully. There was information from the National Forest inventory that gave us some area figures, but they would be treated differently. I think the hedgerow is treated as part of the farmland, and the forestry is treated as forestry. Those rules probably will change in the next couple of years as they bring together land use and agriculture into the same measurement pile within the inventory.
Stuart, was there any assessment done on the different species of hedgerows or any major differences? Question in
That's
relation
that's
to.
that's a it's a good question. There isn't. We have two Wals scholars using this information from the Signpost farms in their PhDs now. They've both been underway a few months, and they'll be looking to see whether we can separate out species. Um, I think the big driving thing, obviously, at the moment is ash. If we can detect ash or what remains of the ash within the hedgerow, we can get some estimate of the impact of ash dieback. Um, Generally speaking, there's not much difference between whitethorn and blackthorn in terms of its biomass. Gorse is different, and gorse is classed as a hedgerow species, but that's often on a bank, and it can be quite tricky to distinguish between the gorse and the bank. So there is plenty of work still to be done to tease out the detail.
Yeah, are hedgerows included in DPA's national inventory, Stuart?
Uh, Not as part of the farmland, I don't think so, no. They will be going forward though, because of they may have been put in the last one as part of the national land cover, because the only information we had was the NFI, so they were just basically put in a very small amount of contribution.
Yeah, and if you're looking at figures, so you're looking at a leaf and woody biomass. If the volume of the hedgerow increases by 100%, does that equate to 100% carbon stored?
Uh, Not quite to begin with. So if you imagine how the plant grows, the new material is a bit looser and less dense than the core of the hedgerow. But the advantage of that is if you did allow the hedgerow to grow and then stop it at a certain size, then it puts its energy into making itself more dense in the new growth area. So even when you allow it to get bigger, you increase the carbon. But then if you start managing from that point, you're also increasing the carbon because it puts that energy into getting denser again.
And sure, you said the LiDAR is 95% accuracy, is it, from your verification?
Yes.
Yeah.
Yeah. And that's a big improvement. I know it doesn't sound like much, but if you think about 85, the difference between 85 and 95% is it means 1 in 20 of your observations are wrong at 95%, whereas 85% is 1 in 6. So, that's the difference.
And using drones for the LiDAR, is that a limitation for the length of time it takes, I suppose, in small areas, or can you upscale it?
Um, it's not a limitation for the purpose we did it. It's expensive. So it would cost about 3 grand to fly each farm. If you're doing large areas, you use aircraft. And the Tolcha Air'n have just bought 2 new aircraft in the last 2 months, and there are plans to create a national LiDAR survey for the country. Whether that'll be made available to everyone, we're not sure yet, but under the National Mapping Agreement. But we'd hope it would be. And that certainly would be the way to go. That would give us, absolutely solid baseline to go forward for the inventory and for looking at things like water quality and biodiversity on the farm.
And just on that, can Copernicus do this for us at a larger scale, or is it limited by the distance? I know it's down to 10 meters, I think you said, is it?
Yeah. So it will. Copernicus is good for sort of pockets of small woodland and scrub and some of the bigger hedgerows. Its accuracy gets less because of this 10-meter limit. It won't pick up smaller hedgerows, and sometimes what will happen is it makes, say, where four hedgerows join together, it makes it look as if it's a much bigger area than it actually is. But what it will do is it gives us a baseline to compare ourselves with other parts of Europe that do have hedgerows and similar-ish landscapes. And we can see over time broad changes, I think, would be important.
So having
And
that national LiDAR map will be important to be able to
Yeah,
measure
yeah.
those changes,
I
I
mean, there
imagine.
are national maps already. There's a company in Cork called Blue Sky, and they have a national hedgerow map and a national tree map created using photogrammetry. So the information is there. It's just a question of paying for it, I think.
And what direction do you see all of this going, Stuart, over the next number of years? Like maybe 10, 20 years ago, we probably weren't able to conceive that all of this was possible. Where do you see the technology going?
Well, essentially, it's in a sort of dull sort of way. It's a form of accounting. So now that we're able to count down to the pennies now, so we'll be able to see very small changes in the Irish farm landscape, and they will go directly into the inventory, and they will change how we understand sort of carbon dynamics nationally and how we pay for them. So we were making very, very broad assumptions. So I think what it means is if farmers do make an effort to increase a hedgerow, they can be confident that that increase and that effort will be recorded and valued, which in the
I'm
past
sure
maybe they weren't always.
from a policymaker's point of view, you can see if a particular policy is working or
Yes, yes,
regulation
yeah,
is working.
yeah.
Yeah, it's yeah, that'll be very powerful, all right. I suppose
And
not all
certainly as this
people.
technology is used within the area management system by the department for CAP, they will see hedgerow removal. And so there will be more, you know, inspections carried out because of that sort of activity, which wasn't done in the past.
there's actually a good few comments around that short where, the farmers can be, there are and should be fined for removal of hedgerows, and you've clearly showed why that's the case. Um, and the reward, I suppose, for holding them on bis as well. But the carbon, it's all about carbon. Are we going to get paid for carbon in future? So are you saying here now that we have records, or we will have records if it comes that they're going to start paying for carbon?
Um, yeah, I mean, to be honest, I'm always a bit. I mean, there's a farm carbon framework that's been developed. It's unlikely farmers will get paid directly for carbon for stuff that's already on the farm. So to some extent, I think the Minister of Agriculture made a point there recently that, you know, under BIS, farmers are already getting paid essentially for the hedgerows because it's one of the conditions of getting the payment is you keep the hedgerows. I think they can be guaranteed that if you plant hedgerows, it can be and you want to get payment for that and to evidence the verification is going on, that's definitely there now. I've always been more in favour of carbon farming by action rather than results. Pay farmer to put down a hedgerow because there's an awful lot of ambiguity on some of these estimates, and there's an awful lot of risk involved. That say there's a fire or something, or the county council tells you have to cut down a hedgerow for safety's sake. That carbon then is lost, and if you're making an account on your farm of carbon for payments, then you might be in deficit. So I'm always more in favour of supporting farmers to do the activity rather than paying for the particular result.
Yeah, and you mentioned about ash there a couple of minutes ago, and I've spoken to a number of farmers in the last couple of weeks who have to remove ash because of the issues
Yeah.
around it. So they're probably concerned
Yeah.
with that. Can LiDAR pick up the likes of hedge laying, or have you come across that in your research?
Um, Theoretically, it can do because of the way it can penetrate through the canopy. Um, you would need a particularly high resolution. So one of the things I didn't mention is when you send out the little pulse of light, you get a return. So if it bounces off something, that's one return. But often the little pulse will half bounce off something. It'll catch the edge of a leaf and carry on. Um, so what you need is a system that maybe can measure up to 6 or 7 of those returns from each pulse, and then you can see what's going on in the structure of the hedgerow. But that's a lot of data, and it would be expensive to produce. And you just wonder what's the cost benefit, because ultimately you'll see the hedge laying. If it's a gappy hedge, eventually you'll see that it's improved or reduced the gappiness, for instance.
Yeah, it really is endless, the possibilities with this technology in the
Yes.
future. Yeah, the Big Brother phrase comes
Yes.
to mind as well, I'm sure, with some people.
I think the way to get around that is to make it as useful for everyone as possible. And
Yes.
then at least everyone gets a benefit from it. And again, from this LiDAR work, the 3 dimensions, it's going to have a really big impact on water quality because you can, instead of just making um, blanket decisions, you can make really field specific decisions about, say, intercepting overland flow for just a small area will have a massive impact.
Yeah, really, really powerful from that point of view. And I suppose we have to remind ourselves that there are many more benefits to hedgerows beyond carbon, between obviously the biodiversity aspect of water quality and water dynamics in the landscape as well. So it's only one aspect that we're looking at, which brings me to a point that we just want to flag an event coming up to people next week, actually. If I can share my screen with you, you can see that there's an event taking place in Castle, which has been organised by our colleague Dr. Catherine Keena. And it's an event being hosted in conjunction with the Heritage Council, where we'll be looking at extensive grassland biodiversity and a very eminent keynote address from Dr. John Feehan from UCD, or formerly of UCD. Many people would know John, who's a real passionate person when it comes to ecology and nature conservation. We are also joined by John Muldowney from the Department of Agriculture and Helen Sheridan from UCD. So a great day, both indoor and outdoor. I think the weather is promised okay for next week as well. So 10 o'clock starting in the County Arms in Birr, and then moving out to Castle in the afternoon, where there's a number of outdoor activities and stands there for people to view. So do try and make it along. You do need to book in. You just go onto the Teagasc website for further details, and there's a full agenda and program available on the website there. So do if you have the time, I think it will be an excellent event to try and get along to. Stuart, we're out of time, unfortunately. We've covered, I think, quite an amount of the questions that have come through, but this is an area that I think we're going to have to keep a close watching brief on, because of just the how quickly the technology is developing, and the great work that you're doing there. So thank you so much for joining us this morning. We're going to be joined by Dr. Cian White next week. You referred to his work there earlier on, Stuart, where he's going to be talking to us about remote sensing of biodiversity on Irish farmland. So looking at that other dimension. So that will be interesting just to see what's happening there from a habitats point of view. And again, is something that we can use to influence management and policy as well in the longer term. So again, yeah, like Carl said, lots of compliments coming through there, Stuart, from the audience this morning. So we really do appreciate you
Keep
coming
them
along
coming.
this morning. Yeah, we'll leave the comment section open for the weekend. So Stuart, just keep them flowing. Carl, thanks so much for helping with questions. You're covering next week's webinar. So until next week, unfortunately, we don't have another long weekend. We were all getting used to them there for a while. But do join us next Friday. And if you can, make it along to that event next Thursday in County Offaly, we might see you there. Okay, thanks.